For these examples, we're converting two logarithmic equations, so converting exponential equations to logarithmic equations, and then converting logarithmic equations to exponential equations. And we're going to do it using the same definition of a logarithm that we've had before. And so we're going to use this log base a of x equals y is the same as, if and only if, a to the y equals x. And so that's our translation between a logarithmic equation and an exponential equation. So we have kind of logarithmic and exponential. Okay, well, if I'm given this in terms of exponential, that means I have let's switch back to the right colors. A to the y equals x, and I want this to be log a of x equals y. And so my y was 3, my a was 10, and then, got a teacher with a tablet trick and slide that over a little bit. My y value was 1,000 there. And so that's my exponential equation that's my logarithmic equation converted from my exponential equation. Okay, let's do the same thing again. I have a to the y equals x is what I've been given here. And so to convert that to a logarithmic equation, I'm going to convert that into my y equals log base a of x. And so my y was -3. So -3 that's going to equal log, and then my base a, that'll be log base 5 of x, and that'll be 1 over 125. And so that will be my logarithmic equation converted from my exponential equation. Now, those two are accurate and true. And you can see that if you take a look at the numbers. This one is where maybe we could say that we can see this becoming a little more useful, because as an exponential equation, this is kind of murky. It's difficult to solve because we got 2.7 raised to the negative unknown value. All I know is I have some exponential decay, and I'm trying to find out where does that exponential decay equal 4,000. Well, without graphing it and looking for, an intersection between two lines like we've done before, I can't solve that. But if I convert this over to a logarithmic equation, well, let's see what happens. I have a to the y equals x, right? And as a logarithmic equation, I'm going to get y equals log a of x. Well, that's going to be my y is -t. And so I have -t as my unknown equals log, and then my base a, well, that was e, and then my x, that was 4,000. And so technically that is a logarithmic equation. We probably wouldn't leave it that way, though. We'd probably multiply both sides by -1 and replace log base e with natural log. And so we'd really probably write that as t equals negative natural log of 4,000. But that is something that I can get a value for really easily. If I write negative natural log of 4,000, now I can come up with that t equals -8.3 is approximately the solution to this earlier equation that was going to be really, really hard to solve without being able to graph both of those and use an intersection tool on a graph. And so it goes from being something that we have to solve graphically with an intersection tool to something where a quick evaluation of a logarithm can give me the solution. That's one of the reasons that we really like these logarithmic functions and the ability to convert back and forth between them quickly. Okay, now let's try going the other way. And so now I have a log base a of x equals my y. And that's going to become a to the y equals x. Well, okay, so it's going to be 7 to the 0.845 equals, I'm sorry, I said 7. That's not my base, right? That's a silliness. That's a big silliness. This log without a base written, that's common log, right? And so this is really log base 10 of 7 equals 0.845. And so that becomes 10, right? Because my a is 10. And so that becomes 10 to the y, which will be the 0.845. And then that's going to equal my x, which is the argument, which would be 7. And that makes sense because raising a number that's larger than 1 to a power that's less than 1 is going to reduce the size of that number. Okay. Let's see if we can't do this one. Now I've got a log base a of x equals y, and I want to convert it to an a to the y equals x. And so that's going to be a t to the k equals q. And I'll admit that's not a terribly illuminating answer, but it is a conversion from a logarithmic equation to an exponential equation. Just like this was from a logarithmic equation to an exponential equation. Now, this is kind of the easier to evaluate, even though we haven't really talked about what to do with that yet. That's coming soon. But what we want to do is we want to convert this over to an exponential equation. Well, we use the same method. We'll say that this was a y equals log base a of x, and I want to convert that to an a to the y equals x equation. And so this is my logarithmic equation. This is my exponential equation. And so what do I have? I have a 4 to the t, not to the 4, I don't know why I wrote that. 4 to the t equals 7 is going to be my exponential equation for that. And so there's a few examples of how we convert back and forth between logarithmic and exponential equations using that definition of a logarithm. Hope that's helpful to you.